Welcome back. My name is Darren Thomas and I am the Director of Educational Research Techniques. In this particular video, we're going to be continuing to learn about data privacy, how you can protect individual people's privacy and information when you're using data. But this time we're going to focus on addressing issues with continuous data while using Python as our primary tool. So let's go ahead and see what we can learn. Okay, so we're inside our Jupyter. And so this is the first little set of code we're going to run. We're going to load two libraries for now, PyDataset and also Pandas. So go ahead and run that. Everything's set up. Next thing we're going to do is we're going to deal with our data. So that's going to be in this next cell right here. And so we're going to use the SLID data set. We're going to pull that data from the PyDataset library using the data function, and we're going to save it as an object called df. And then in this next line, we're just going to take a quick peek at the first 5 lines of the data set so that we have an idea of what we're dealing with. So we ran that. So you can see that the SLID data set has 5 variables: wages, education, age, sex, and language. This is the data that we're going to be trying to manipulate in order to protect privacy for various reasons. Now, the first thing we're going to do is we're going to look at a histogram of the age variable. That is the main variable we're going to address in this particular video. Age obviously is a continuous variable. That means, it has a nice distribution. It has a mean, median, and mode. It's spread out. There's infinite number of potential values within it. And so let's just see what the default histogram looks like. So right here, we're pulling the age variable. And then right here, we're using the method hist with 15 bins. And this is going to give us a picture of this particular variable. So there you go. This is what it looks like without making any adjustments to it. So this is going to be our before picture. And as we continue to move through this video, we're going to manipulate this variable to give it different appearances. And then you can be able to see the difference in how the shape of the variable changes based on how we manipulate the data to protect people's privacy. All right. Now, one simple way to address privacy is to change the variable from being continuous to categorical. And so we can do this several different ways. The way we're going to do it is going to involve using an anonymous function. So let me go ahead and show you the code for this. And what we're doing here is simple. Right here in the highlighted part, we are calling the age variable here. So df with the square brackets. Then we're going to override it using the equal sign. So we're going to override it. You can make a new variable or you can just manipulate the existing variable. It's up to you. And so on the right of the equal sign, this is how we're going to change it right here. So starting right here, we're going to call the age variable again, and we're going to use the apply method. That's what we're doing right here. And inside the apply method, we're going to write an anonymous function. That's what this lambda stands for right here. So inside the age variable, x is just kind of like a stand-in variable. So for x, if the value is greater than 40, we're going to use this right here. If the value is, I'm sorry, right? Okay, so we're going to put x is greater than or equal to 40 if the value is greater than or equal to 40. Everything else is going to be recoded as less than 40. That's what we're going to do right there. So we're going to use this to have 2 categories. So we're going from a continuous variable, which has an infinite number of potential values, to a categorical variable that only has 2 values. Now, it doesn't have to be two values or 2 groups. You can make as many groups as you want. But for our purposes, we're making 2 groups. So let's go ahead and run this so you can appreciate this. And so here, this is our new age variable. Now before, in this particular column right here, that you can see that I highlighted, we used to have all kind of different ages, 40, 55, 60. You can see from the histogram, these are what we had. But now, through using this anonymous function right here, we have 2 values. So for example, row number 1, this person has an age that is equal to or greater than 40. And if we go back to our original table, you can see this person is 40 years old, which is equal to or greater than 40. And then the next row, you can see this person was 19. And if we go down here in row number 2, this person was coded as less than 40 because 19 is less than 40. So that's what we have. Everything is going according to plan. Now, let's just take another look at this. We're going to make a table first, and then I will make a bar graph of these two groups. So here we go. So here's kind of a simple table where we just use the value underscore counts method, and you can see it's about 55, 45. So we have almost 4,000 people who are greater than 40, and over 3,400 people who are less than 40. And of course, we're going to make a quick little bar graph so you can see how things have changed. So we're going to import the Seaborn and the matplot.pyplot libraries to make this. Then we're going to call Seaborn count plot. We're going to map age, and we're going to use our data set called DF, and then we're going to show it. So if we just run this real quick, you can see it in a second. And you can see right there, this is our two groups that we've just created. And this right here is a huge difference from our original histogram. That's how we were able to transform the data. And so again, you might do this to protect privacy for whatever purpose you might have. Like if there's a few values over here, you might be able to identify who the person is, and you want to protect those minority groups, if you will, by moving them into a larger group, if you will. Now, for the next two, they're kind of the same ideal, just from different size. Top coding is when you take values above a certain threshold and pull them down to that maximum value. And bottom coding is where you take values below a certain threshold and bring them up to a certain value. So let's go ahead and take a look at this real quick. So here's what we're going to do. So the first thing we're doing is we're going to rewrite our DF data set so that it's the original values again. Because remember, we manipulated the age variable. That's the first line of code. In the second line of code, what we're doing here is we're telling it to locate using the loc method inside the variable age, all values that are greater than 75, set them to be 75. So what's happening here, if I had to show you, is all these values up here in the 90s and 80s, these are much older people. We're pulling these values down to 75. So they're all going to get pulled down here. Again, you might want to do that if you have a handful of outliers, but you still want that data and you want to protect people's identity because it's an unusual value. You can pull them down to a certain threshold. Now you lose some of the benefits of the age variable. However, you are doing this to protect identity. You're not doing this to develop insights into the data. That's what's going on here. So now what we're going to do is run this code and take a look at it. Oh, by the way, the last line of code here is just going to show you the histogram. So let's go ahead and take a look at this. All right. So you can see right here that there's a major difference. Look at this value here. See how there's a lot of people who are age 75? That's because we pulled these people from up here. There were some 90-year-olds, some people who were 80 to 85, etc. All these people got pulled down to right here. And so that's how we're able to do that. Now, bottom coding is the same idea. Instead of pulling from the top, we're pulling from the bottom. So let me just show you this real quick and we'll be done. So it's the same basic idea. The only difference now is instead of being greater than something, it's less than 20. Anything that's less than 20, we're pulling it up to be a value of 20. It's the same basic idea. It's just that what are you trying to deal with? Are you trying to deal with the top or the bottom? And there might be times when you want to deal with both. It all depends on the situation. So here we go. Here's our new histogram. Now notice how the values above 80 are back. These are back here. But now the values down at 20 are much more now. So this is top coding right here. And this is our original histogram right here. So you can see we had a lot of people who were below 20, a lot of 19-year-olds. They got moved over, and so this shot up here like this. So let's go back down to the bottom. And you can see how the values at 20 shot up really high to over 1,000. And that's another way that you can address and deal with protecting people's privacy when you're dealing with that as a concern when you're dealing with data. So that was the main tools that I wanted to show you. Let's summarize this video and wrap it up. So in this particular video, we looked at how you can try to protect people's privacy using Python with these various tools. The first and probably the most common way to deal with this is to just make the data categorical. And so we set it to where if they are greater than 40, set it to this value. If they're less than 40, set it to this value. And so instead of having continuous data, you now have categorical data that has two groups. And then we made a bar graph of this so you can see how much has changed from a histogram. This is definitely not a histogram anymore. We also looked at top coding and bottom coding. Top coding is when you take values above a certain threshold and bring them down. As you can see right here, we brought the people who were above 75 down to being 75 years of age. And bottom coding is where you bring values below a certain threshold up. So in this example right here, people who are below the age of 20 were brought up to being the age of 20. And again, this helps to protect the identities of people who are extremes so that they're more brought towards the middle. And so you're not able to find out who that individual person is, as an example. So I would like to thank you again for watching and listening. My name is Darren Thomas. I am the Director of Educational Research Techniques. You have a good day and you take care.